And it's done the same way that we did the linear regression. Okay? You're going to plug in 3 points. So you do need 3 points, though, if you're going to use regression for a quadratic. You need one more point than the dimensions of your, or the degree of your function. So with a linear equation, we needed 2 points, right? The highest degree or the highest power of a linear equation was 1, so you need one more point than the degree. So in a quadratic equation, which is the highest power of 2, you need 3 points for it. Well, we have 1 point and 2 points. So in order for us to find the other piece, what we have to do is understand the symmetrical nature of a parabola. So when we move from the vertex up and over to find this given point, we can find another point mirrored across that here at the same y value. So this is going to have a y value that's the same as 5. But the x value is going to change. So when we move from -2 to 0, how many places did we move horizontally here? 2. So how many places do we move horizontally in the other direction to mirror that? Also 2. Okay, so what coordinate is 2 units to the left of -2? -4. So there's our other point. So by doing that, okay, so by using the symmetrical nature of that parabola, you can find a third point. And once you find that third point, now it just becomes a regression equation. So you'll use the data matrix editor. Okay, and so to refresh your memories on that, okay, we go to our apps, choose data matrix, and just open the current one. Okay, I'll clear this screen so we can re-enter everything. Okay, enter the points, the coordinates that you have. So I have -4, 5. So my x coordinates are -4, -2, and 0. My corresponding y coordinates are 5, -3, and 5. So there's my coordinates. I hit the Calculate tab, F5. But this time, instead of choosing linear regression, which is what we did last time, we're going to scroll either up or down. I know it's at number 9, so I'm going to scroll up to Quadratic Regression. Okay, so you're going to use Quadratic Regression in this one. And then everything else stays the same. So you're going to identify to your calculator that the x coordinates are located in column 1. So you'll enter C1 for x's. Your y coordinates are in column 2, so C2 for the y's. Go ahead and store this regression equation in the y editor. And when you do that, instead of it coming up like it did with linear regression as y equals ax plus b, it comes up as y equals ax squared plus bx plus c. That's standard form. And so you know that your equation for this is going to be an a value of 2. So 2x squared, your b value plus 8, and your c value plus 5. Okay, so now this is standard form. So all you needed from this, if you were going to choose the regression method and using your ti89, all you need to know is what a is, because you already know what hk is. So you already know this part of it. So the regression is just going to tell you what your a value is, and you plug that in right here.